Hello and welcome back. Sorry, we had an alarm go off. So, we are on constraints now. So, we have $85 to spend and wants to know the maximum number of pepperoni pizzas. Well, if we have $85 to spend, if I divide that by my cost of pizzas, I can get an idea of how many pizzas. So, this says I could get 5.4 pizzas. Can't get part of a pizza, so we can get 5 pizzas. So 5 times 15.49, and that would cost us $77.45. So the maximum we can get is 5 because she can buy 5 pepperoni pizzas and 0 cheese pizzas without going over budget. The minimum number of each type of pizza she can buy is 0 because you cannot buy negative pizzas. Right. The minimum is 0. We can buy none. Solve for C, the cost of a cheese pizza. All right. Subtract 15.49 from each side. We are solving for C, so that means our variable with coefficient must be isolated over here. This needs to be moved to the left. Like terms cancel out. From here, we need to divide both sides by the cost of the cheese pizza. This is going to isolate C by itself, so we're dividing both sides by 13.49. We get a cancellation over here, leaving C, and we're left with this fun fraction, t minus 15.49, p divided by 13.49 equals C. If Kishi has 85 to spend on pizza, needs to buy 3 pepperoni pizzas, find the maximum number of cheese pizzas she can buy. Okay, that's easy. So, we just solved for this formula here. Then what we have is we can give the maximum and how many pepperoni pizzas we buy, and it'll tell us how many pizzas we can get. All right, so we're going to substitute in. We have our T, and we have our P, and P is the number of pepperoni pizzas. So we have our total cost minus the cost of our 3 pepperoni pizzas. That money that is left, we are dividing by the cost of a cheese pizza. We get 2.86. Now, since we're talking in whole pizzas, we can't have part of a pizza, so we must round down. So we can only buy 2 cheese pizzas. So over here, why do we say 2 instead of 3? You can't buy 0.86 pizza. We only have enough for 2. Check. Ella makes a video game that becomes very popular. She creates a formula. P equals 40C minus 300 to model her profit given the number of copies sold C, taking into account the 300 fee that she has paid a retailer to sell her game. Which equation would model how many copies C must be sold? So we're taking this to find a specific amount of profit. Which equation would model how many copies must be sold to yield a specific amount of profit? So we have P, we're going to have to add 300 to both sides. So it should be P plus 300 divided by 40. Because with this, if we know if we know the profit we're looking for, we can plug it into this formula and it'll tell us the number of copies we need. Why might we want to convert units? Hey, NASA didn't convert on one of our first probes we sent into the South Pole of Mars. NASA offloaded its calculations to the EU. Scientists in the EU took US miles, converted them to the kilometer, did all their calculations in kilometers, sent the data back in kilometers. NASA then didn't convert back to US miles, put in the data as miles instead of kilometers, and crashed the probe. So yeah, converting units is very nice. Dimensional analysis. When using formulas, you may want to use dimensional analysis. Dimensional analysis, or unit analysis, is the process of performing operations with units. As you plan your solution method, think about what units were given, what units you need for the solution, and what steps you need to take to convert your units from what you are given to what you need for the solution. Example 5. Multiply by a conversion factor. Mark is purchasing an above-ground swimming pool. The salesperson says the pool can hold 97,285 liters of water. If 1 gallon equals 3.785 liters, determine approximate how many gallons of water Mark's pool will hold. Two ratios can be used to compare liters to gallons. 1 gallon divided by 3.78 liters and 3.785 liters to 1 gallon. To convert from liters to gallon, multiply by 1 gallon over 3.785 liters. So we have 97285. As they show, the liters cancel out, so we are left with gallons. So on our calculator, 97285 divided by 3.785. And that gives us 25,702.44. 25,702.77411. So if we were to approximate that, I'd say 225,700 gallons is a good approximation. It's a little bit more. We could even round it up to say approximately 26,000 gallons of water. It's 300 gallons shy, but we're rounding. For the chefs to prepare the dish for the next hour, Adela needs to provide them with 96 cloves of garlic. However, she can only purchase bags of whole heads of garlic. Each bag of garlic contains 3 head, and each head has 8 cloves. How many bags of garlic should she purchase? All right. She needs 96 cloves. And it says there's 8 cloves in 1 head. And each bag contains 3 heads. 3 heads to 1 bag. So what I did is I started with what we're looking for, and I set it up to cancel cloves. So if cloves are right here, I need them to be on the bottom, and that sets up my fraction. So we see cancel, so it'll be 96 divided by 8 divided by 3. What assumption must Adelina make when tongue-tied, when calculating how many bags of garlic to buy? Each head of garlic has exactly 8 cloves. Yep. The chef needs 96 heads of garlic. No, not that. The chef needs 96 clothes. Yep. Each bag has 3 heads. Yep. Those must be true. How many bags of garlic should they purchase? So, by our cancellation, 96 divided by 8 divided by 3. So 96 over 24. 4. 6. Use dimensional analysis to convert units. Recipe calls for 20 fluid ounces of milk. If Nita buys half a gallon of milk, how many batches of that recipe can she make? 8 fluid ounces equals 1 cup. So this is a giant conversion tree. So we have 1 gallon is 4 quarts, 1 quart is 2 pints, 1 pint is 2 cups, 1 cup is 8 fluid ounces. So gallon to gallon. Quart to quart. Pint to pint. Cup to cup. And we are left with fluid ounces. So doing this, we get 64. Nita has 64 ounces of milk. Each batch calls for 20 fluid ounces, so find the number of batches she can make. 64 divided, this is going to be 3. It's going to be a little bit over 3. So 64 divided by 20 gives us 3.2. Ounces cancel, so we have batches. So approximately 3 batches. When you're converting, how do you know which units go in the numerator and which go in the denominator? Again, if you start with gallons, the first one you want to set up is to get rid of the gallons. So if your first number has gallons in a numerator, the next one needs gallons in a denominator. Check. On average, a dairy cow produces 832 ounces of milk a day. About how many gallons of milk does a dairy cow produce each year? All right. So we have 8320Z per day. Z to 1 cup. 4 cups to 1 quart. 4 quart to 1 gallon. And then a year, since we have days down here, we want this to be years. So we got gallons up here, all right, ounce. Then I have 365 days to year. Now double check. Days cancels days. Ounce, cup, quart. So I'm left with gallons per year. All right, I needed gallons per year, so 832 divide by 8 divide by 4 divide by 4 times 3 365. 2,372.5. Converting rates. In a novel, the main character Aiko can run long distance at 16.5 janjaku per second. Carla knows that the Olympic record for running a marathon distance of 26.2 miles is about 126.5 minutes. She wondered if Aiko could beat that record if one kanjaku is 1033 of a meter. Find how far Aiko could run in miles in that amount of time. 1 mile is approximately this many meters. Use the formula distance equals rate times time. That relates distance, rate r, and time t to find the distance. Setting up that formula, we have 6.25 janku over 1 second. In order to compare Aiko's to Olympic runner, convert Aiko's rate of janjaku to miles per minute. Convert the distance, rate in jaku per second, and this needs to be converted into minutes. I think we're going into miles per second. All right. So we set in our conversion factor, get our new units gotten rid of. Then meters to miles. All right, next set convert time. We want time in minutes. But it is currently in seconds. Use the resultant rate from step 2 to convert. So we have 5 miles in this many seconds. So we're going to multiply that by 60 seconds to 1 minute. Seconds cancel. So we have 300 divided by 1609.344 minutes. So let's take a look. The time they're using is 126.5 minutes. Okay, and the reason why is we have our speed and the time it took. So we're going to convert that to see if in 126.5 minutes how far they're going to go. And this gets us down to 23.6 miles. So Aiko would run about 26.3 miles in the time it took the Olympic runner to compete 26.2 miles. So Aiko would not beat the Olympic runner in the marathon. All right, take a moment to pause. Think about anything you might have struggled on, needed some extra guidance. This is the last section, 2.7. See you next time for the review.